In this tutorial, we'll learn how to create the same Mograph setup in both Cinema 4D and Houdini. If you are a Cinema 4D user looking ahead to learn Houdini, this tutorial can show you the very different approach Houdini and Cinema 4D take to content creation. First, we create the setup in Cinema 4D and render it using Arnold Renderer. Then we move to Houdini and create a very similar setup there as well. The last thing to do is to export the Houdini scene back to Cinema 4D using Alembic, adjust the shaders using the point data we got from Houdini, and render it using Arnold again. So get some coffee or tea and let's get started. Hey folks, welcome to MographPlus. Be sure to subscribe and ring the bell to get notified about our latest videos. Make sure to visit our website MographPlus.com or our Gumroad page at gumroad.com/MographPlus and check out our premium rendering and motion graphic courses for Cinema 4D, 3ds Max, Maya, Arnold, Corona, Viri, Maxwell, and so on. Before starting the tutorial, I want to make a disclaimer. After you finished watching this tutorial, especially if you have no previous experience using Houdini, you probably say to yourself that, oh my god, Cinema 4D was way easier compared to Houdini and Houdini is very convoluted. And that's not entirely true. I do not mean for this tutorial to be discouraging for people who want to learn Houdini. Once you start learning Houdini, you realize it makes sense. Yes, it is hard to get started, but once you understand the logic behind how Houdini works, you start rolling and loving the software. So don't get discouraged and realize Houdini can do much more, but it takes more time to set up. At the same time, as the users of this channel are mostly C4D user, the Cinema 4D part will be much quicker as I don't have to spend time explaining some of the key fundamentals. But the Houdini section is purposefully longer as I needed to explain a lot of key concepts that might be alien to C4D users, and that make it like the Houdini part is like more complex and take way longer. But for even a beginner Houdini user, the setup might take only twice as long in Houdini as in Cinema 4D. Here is what we are trying to create in Cinema 4D. We have a cube and a cylinder being cloned in a grid array mode, and we want to increase the Y scale of these clones in a pattern like this. Then we add more randomization only to where the clones are having a bigger Y scale, and finally we make sure the clones scale down to 0 near the edges of our circle. It's a fairly simple setup in Cinema 4D, so let's get started. First, create a 10 cm by 10 cm cube. Press C and make the cube editable. As I want to scale up this cube from its base in the y-axis, let's put the pivot to the base of the cube in the y-axis using the axis center. Now let's add a cylinder. Set its radius to 5 and height to 10. Change its height segment to 1 as we'll be having a bunch of these clones, so keeping the polys low is a priority. Make it editable and put the pivot to the base as well. Now add a cloner and put the cube and the cylinder under it. Change the mode to grid array. And as the cloner is using the iterate mode by default, we get 1 row of cubes and 1 row of cylinder. These are the stuff Cinema 4D gives it to you for free, but you have to work for them in Houdini, and you will see. Now set the instance mode to multi-instance for faster feedback, and set the X and Z count to 50 for now. I'm going to add a plane effector to the cube. Under the parameters tab, disable position and enable scale. And we want to set the Y scale to 7, and that's pretty much it. Now we can start creating the pattern we want using fields. So in the fall of tab, add a spherical field. Set its size to 250 centimeters. And inner offset to around 20% so the effect will be more gradual. In the remapping tab, change the contour mode to curve. And now we can adjust this curve to get exactly the shape that we want. Let me just adjust the curve a bit. In the color remapping tab, let's use a purplish color. So that is the first effector. Let me quickly rename the plane effector to plane 01 and our spherical field to spherical field 01. Select the cloner and add another plane effector and rename it to plane 02. Under its parameter tab, disable position and enable scale and uniform scaling, and set the value to -1, which makes our clone disappear. Add a spherical fill to this as well. I want to use this spherical fill to make the clone disappear at the very edges of our setup. I do not want it to affect the clones in the peak that much, probably just make them a bit smaller, but I need it to be more effective in the valleys compared to the peaks. So I'm going to set the size of this fill to 250 centimeters as well. And like the previous field, let's decrease the inner offset to around 20% so the effect of the field is more gradual. We can change the contour mode to curve, and we can probably copy the curve from our previous spherical field and adjust it a bit. So I'm going to copy and paste the curve and invert the strength and start adjusting it to get the desired effect. If I turn off the first plane effector, you can better see what this second plane effector does. Also in the color remap tab, change the color to this cyanish color with the RGB values of 27, 182, and 224. Now that we are getting closer to the final effect, let's increase the clone count to 70. And also turn on our first plane effector, and this is the combined result we get. And lastly, I want to add a bit of randomization in scale based off of the current spherical field that we have, and we can do that using the same plane effector. So just add a random field and change the random mode from noise to random. Set the max strength to around 75% and make sure this random field would not affect the existing colors at all. Now to limit where this random field affects, we can simply add a mask to it and use our existing spherical as what derives the mask, and that's the basic setup in Cinema 4D using fields. And now we can start the render using Arnold. If you are not interested in rendering, you can skip the video to where I started in Houdini, but I think it's essential that you watch because there are some points that is related to rendering and I will be mentioning them when we get back to Houdini, so just continue watching. It will take only a few minutes. Now let me quickly go to my Arnold layout. I have this basic scene set up that we can enable them one by one. Let's run the IPR as well. We have this simple area light as our light source. I have this floor with a simple diffuse blue standard surface shader applied to. There is this white cube that acts as a reflector and brings back some light into the scene, and we can go and view the scene through the camera as well. Now, how can we get Arnold to show us these colors in the render? If we create a new Arnold standard surface shader and assign it to our clones, let's run the IPR as well. You notice the colors are gone both in the viewport and they are not showing up in the render as well. That's because Arnold can't read the MoGraph color data by default. Let's middle click on the material to open up its network editor. To read the colors from your Mograph setup, you need a node called user data RGB. So press Ctrl and Tab and get a user data RGB node. This node can read existing attributes in your scene, both custom and native, and one of the native attributes is the display colors of your clones, and you can define that attribute in this attribute field. If you click on this arrow besides the attribute field, we can read bunch of xparticles attributes, or we can select this display color from our Mograph setup. So let's choose that. And if this arrow doesn't exist, you manually type in display color to load that attribute. Now that we have this attribute load in, I can simply connect the output of the user data RGB node to the base color input of the standard surface shader. And now we get our clone colors in our Arnold render. Let's just set the base weight to 1 so we are using the full range of our color data, and that's how you do it. While we are here, we can do a few cool things. I can simply add a color correct node after the user data RGB node, and use the hue shift value to get an entirely new set of colors for my clones. For now, let's set the hue shift to 0 to get the original colors back. Now let's do a bit more. I just want to simply multiply the existing color data with a random black and white value per clone. So first we need to generate those black and white colors per clone, and to do so we can use a simple color jitter node and set it as the beauty shader for now. I'm going to set the input color to black, and under the object section set the gain min to 0 and max to 1. And now we have this random grayscale clones. Now we can get a multiply node, connect the color correct node as the first input, and the color jitter as the second input, and use the multiply node as the beauty shader. I'm going to set gain min to 0.5 so we don't get very dark clones, and set the max to 1.5 to get a bigger range of colors. Now set the multiply node as the base color for the standard surface shader, and connect the standard surface shader as the beauty shader. And that's it. Now let's go for the same setup in Houdini. Here we are in Houdini 18. Add a geometry node. Let's start with a basic box. We use a simple expression to make sure the cube always stays on top of the grid no matter the height of the cube. And to do that, simply right click on the size Y of the cube and choose copy parameter. And now right click on the center Y and paste relative reference and divide it by 2. So we are basically telling the center Y parameter to use the size Y divided by 2. Now if I increase the size Y to whatever, the center Y value will be half of that, and therefore the cube will stay on top of the grid all the time. I'm going to set the size to 1 for now. Add a transform node to the cube and let's make it smaller. Just set the uniform scale to about 0.09. Now let's add a tube, which is basically the same thing as a cylinder. I'm going to change the primitive type to polygon, enable end caps, the height to around 1.7. And to make sure it always stays on top of the grid, we can use the same technique. So simply copy the height value and paste it at the center Y and divide it by 2. Now let's add a transform node to this tube as well and set the uniform scale to 0.05 or 0.052 to be a bit more precise. Now the cube and the tube are roughly the same size. Now we need a grid to copy this cube and tube onto. So add a grid geometry, set its rows and columns to 70 and 70 like we had it in Cinema 4D. I don't necessarily need the grid itself, just its point to copy my geometries onto. We can use an add node to achieve that, so add one to the grid and enable delete geometry but keep points. For now, let's think about how we can copy the cube onto these points. We take care of the tube later on. To do so, we can use a copy to points node. This node takes 2 inputs. The left input is for the geometry we want to copy, so let's connect our cube to it. And the second input asks for the points that we want this cube to be copied onto. So let's connect our grid and enable the display flag for the copy to points node. The next thing I want to do is to create that first spherical field that we had in Cinema 4D. So let's add a sphere to the network. Turn on its template flag to see what's going on. As the sphere type is set to primitive, if I take a look at the node info, you notice this sphere has just one point and that point is in its center. It doesn't consist of polygons and we want the fall off to be around this point and not the sphere itself. So keep that in mind. I will add a transform node to it so we can move it around later easier, as this will be the main driver of the entire setup and this will kind of move our fall off. In Houdini, you don't affect the clones directly. You work on the points that the cubes are being copied onto, and then the copy to points node will copy those attributes like scale and randomness to the copied geometries. First, let's create a fall-off around our sphere. To do that, we use a node called mask from geometry. Connect the grid points to the left input and the sphere to the right input. In the mask node, we want to change the reference group to points, as we are only interested in that point in the center of the sphere, as I mentioned. To see and visualize the mask or the field, if we use Cinema 4D's terminology, let's click on this toggle visualize button, and now we can see the mask. And we can increase the radius to make the mask bigger. Let's set the radius to 5.5 for now, so it covers all the points. If you take a look at your geometry spreadsheet, all the points on the grid have an X, Y, Z position attribute, which is a vector attribute, as it has 3 float values, which defines their position in 3D space. Basically, if you take a look at the spreadsheet, on the left side, you have the point numbers from 0 to the last point, and on the right side, you have the attributes and the value of each attribute for each point. And now we have created another point attribute called mask, and we can rename it to whatever we want in the output mask field. So we can rename it to, let's say, falloff, for example. And now it's called falloff in the geometry spreadsheet as well. Let's rename it back to mask. So basically now each point has a value or an attribute attached to it, which starts from 0 to 1 per point. This attribute is called mask, and the points that are closer to the center of the sphere having a higher value close to 1, and the points far away are gradually get closer to 0. And now we can use this mask value or attribute to control anything we want. We can control the scale of our boxes, for example. So if a point has a mask value of 1, keep the size of the box that is being copied onto that point to 1, and if the mask value is 0, change the size of the box that is being copied onto that point to 0 as well. If I get the transform node attached to our sphere and move it around, you notice how, like a spherical field in Cinema 4D, we can move our field or mask wherever we want and control everything from here. For now, let's make sure it's at the center. The cool thing is that the mask from geometry gives us a curve to remap the mask values, and even if it didn't, it's Houdini, so you could simply create your own custom curve using a wrangler or an attribute VAP and adjust the values there. And now we can use this curve to create a similar curve to what we had in Cinema 4D. So I'm just gonna create a similar curve. Now, we're not going to follow the exact same steps we followed in Cinema 4D. It's Houdini, it's different, so we're going to approach it differently. Now, I want to add a scale attribute to all the points. Scale is a built-in attribute in Houdini. It's a vector attribute which allows us to control the scale of the points and therefore of our boxes on X, Y, and Z separately. So add the attribute create node. The name of the attribute is scale with small letters, and as soon as we type that in, Houdini knows what to do with this attribute. And now a new attribute named scale is added to our geometry spreadsheet. Right now, the data type for our scale attribute is float. It's just one value. And scale is a vector attribute with 3 values on X, Y, and Z. So change the data type to vector, and now we have scale X, Y, and Z as it is reflected in the spreadsheet. Now, if we connect the attribute create node to the copy to points node and enable the copy node as well, you notice all the cubes have disappeared, and that is because the scale is set to 0 by default. And if I set the value to 1 on X, Y, and Z, we get our original boxes, and that is because the value that we defined for the scale attribute is 1, 1, and 1 on all the axes. If I get back to the attribute create node and set the scale Y to, let's say, 5, you notice the boxes are becoming 5 times larger on Y, and the same thing can be done for X and Z axis as well. For now, let's set the value back to 1. So the fundamental concept here is that we create attributes on point. Then when we copy any geometry on those points using a copy to point node, the attributes of those points will be copied onto those geometries. The next thing I want to do is to add a bit of randomness to scale Y. So let's add an attribute noise node. By default, it randomizes CD, which is basically color. We want to change that to scale. So let's type in scale, and now it randomizes scale. I'm going to set the Z and X min and max to 0 and 0, so they won't get randomized at all. And let's set the Y min to 1. So we get our original cubes back, and set the Y max to maybe 1.2, 1.3 to add a bit of randomness. And if you want more randomness, you can obviously increase this value here. You notice the noise is a bit too large, so I'm going to set the element size to 0.05 to get a smaller pattern. So now we have created a scale attribute and randomized it on y-axis. Now it's time to utilize the mask and scale the boxes on y based on the mask values. So if we get our scale y value and multiply it by our existing mask values, the cubes will be bigger when the mask value is 1 and smaller when it is 0. Simple enough. And to do that, we use Houdini's version of Espresso, which is called attribute VOP, and it is a visual way to generate VEX code in Houdini. So add an attribute VOP node and rename it to something like scale mask or whatever it makes sense to you. Let's make sure the copy to points is enabled and press enter to go inside the attribute VOP node. As I mentioned, we need to multiply the scale y value with our mask value. So we need to bring in those two attributes. To bring in attributes, if they are not already in these VOP global parameters, and here you can see we have P for position, V for vector, CD for color, diffuse, and so on. We can use a bind if we can't find that particular attribute here. So add a bind node. The attribute we want to bring in is called scale, and scale was a vector, so make sure the data type is correct. Next, add another bind. This time we want mask attribute, and if you recall, mask was a single float value between 0 and 1. Now, scale is a vector consisting of 3 float values, and we want to work with the second value, which is scale y. So add a vector to float node and connect the scale attribute to it. Now add a multiply node. Connect the float 2, which is our scale y, to the first input, and our mask to the second input. So the first part is done, and now we need to repackage the whole thing and fit it back to the scale value. So we need a float to vector this time. So x is the original value and z is the same thing, but y is the result of the new value we made. Now to export the scale value, we need a bind export. So get a bind export. Name it scale. Type is vector. And now the changes are visible in the viewport, and the cubes are having a bigger scale y value when the mask values are bigger, and vice versa. Now I want to amplify this, and to do that we will multiply our values with a value bigger than 0, so bigger than 1 actually, so at a constant node. And connect it to our existing multiply node as the third input. And let's set the value to, let's say, 5, and now everything is amplified 5 times. Great. If you remember back in Cinema 4D, we made the clones disappear close to the edges of our setup, so let's do that while we are here. I talked about scale attribute being a vector attribute with 3 values for x, y, and z. there is another attribute that controls the unified or uniform scale for all the 3 axes at once, and it is called P scale. If you remember back in Cinema 4D, we created that second plane effector and set the uniform scale back to -1 and copied our first spherical field and adjusted its curve to control where it would affect the clones. So here in Houdini, we use, P scale. So let's tell Houdini we want to control the P scale, which is the same as uniform scale. So we need to add a bind export. The attribute name is P scale. Now P scale, unlike scale, is just a single float value, so the type can stay as float. And we want to control the input value with our mask. So connect the mask to our bind export for the P scale attribute. So basically what we are saying here is that where the mask value for a point is 1, keep the original size of the clones, and where the mask value is less than 1 and closer to 0, use a smaller value for the uniform scale, which in turns make the clones almost disappear where the mask has no influence in the values of our shape. Now that's cool, but I want a way to be able to customize these mask values for the P scale to control where exactly it affects the clones. So we can put the mask values through another curve or ramp before connecting it to P scale and use that curve to specify how the mask values affect the P scale. So press tab and add what's called a ramp parameter node. And let's give it a descriptive name like uniform scale ramp. So change the ramp type to spline ramp and connect it to our P scale input. And now we can customize our mask values for P scale specifically. Traditionally, you don't control your ramp inside a VOP network. You go back up to the geometry level, and here we have our uniform scale ramp. And this is a simple ramp with 2 points. The left one controls the low values of the mask input and the right one controls the high values. So if I move up the first point, I make the lower values bigger, and therefore our disappeared clone will become bigger. And if I lower the second point, I make my already present clones to become smaller. I just want to make sure only the clones at the very edges completely disappear and keep the more central clones less affected. We just add 2 points close to our first point and make the curve to stay at 1, only to dip suddenly near the end, and this will give us our desired effect. Cool, the effect is almost done. Now it's time to add the tube as well. Right now only the box has been copied onto the points, and we want to separate our points into 2 groups and copy the box on one group and the tube on another. So I'm going to enable the display flag on our attribute WAP, which is our last node before going to the copy node. Add a node called group by range and enable its display flag. Let's name this group box, just so we know these are the points that we want to copy our box to. Change the group type to points. In the range filter section, we want to select one of each 2 points, and this will be the points that we copy our box to. Now we need to group all the remaining points for our tube. So add a node called group combine. Name the group as tube, and the group equals all but the box group. And this will select all the points that are not in the box group and creates a group out of them named tube. If we come back to our copy to points node, right now the box is the geometry we are copying. So in the copy to points node, change the target points to box group. Now add a new copy to points node and connect the tube as the geometry to copy. Connect the last node in the right chain, which was our group combine node, as the points, and enable the second copy node and change the target points to tube this time. Now we have 2 copy nodes, one copying the box and the other one copying the tube on their specified points. Now if we merge the 2, we can get the final effect. So add a merge node and connect both of the copy nodes to it. And that's our final combined effect. Now, before thinking about exporting this back to Cinema 4D for rendering, let's create some color based off of our mask. So I'm going to add a color node. Again, we want to color the points, and then the clones will get those defined colors via the copy to points node. So I'm going to add the color node after the group combine node and change the color type to ramp from attribute. And the attribute we want to use is called mask, which is the mask we generated at the beginning using mask from geometry node. And now we can change the black and white color to any color we want, or add in between colors as well. So change the white to purple and black to this kind of cyanish turquoise color. Add a color in the center and change it to a more kind of bluish color. And now we have colored our clones, very close to what we had in Cinema 4D. If we export this back to Cinema, this color data will be saved in a vertex color tag. I don't need to use this, we just need the raw mask data, and then we can use that to color our clones in the rendering phase using Arnold. Right now we have the mask attribute and it will be saved as a vertex map. Remember, back in Cinema 4D we used the color jitter node in Arnold to get the random black and white clones. Now I need to generate that data here so we get that as well when we are back in Cinema 4D, as the color jitter node wouldn't generate that for a single unified alembic file. So let's add an attribute create node before or after the color node. Remember, we used this node to create that scale attribute at the beginning, and here the attribute name can be anything. Let's name it like random BW, random black and white. Obviously the name can be anything you want, and as we want just simple grayscale values, type can remain as float. If I turn on point number display for the viewport, you can see each point has a number from 0 for the first point to 4,899 for the last point, and that point number can be accessed in our network using ptnum attribute. For the value, we use a function to generate random values between 0 and 1 based on the point number of our geometry, and that function is called rand. So for the value, type in rand, open parentheses, at ptnum, close parentheses. So we are using that @ sign to access the ptnum attribute. So we are generating a random value between 0 to 1, and that's what the rand is for. We are generating a random value between 0 to 1 based on the point numbers. Now let's get back to our geometry spreadsheet. We have a new attribute for all the points, and each point gets a random value between 0 to 1. And we can visualize that as well. So I'm going to add a new color node on this side and connect the attribute create node to it. I'm going to change the color type to ramp from attribute, and the attribute we want to colorize is called random BW. Now if I zoom back and turn off point number display, we have basically generated that black and white randomness per point. Perfect. Now if I enable the merge node and take a look at its info, we have 4 point attributes. We have our CD, which is color diffuse, and this is the purple cyan colors we generated using the color node. We have our mask and random BW, which are single float values, and our position or P, which is a vector attribute. And now we can export this to Cinema 4D and render it there. For that, we need a ROP alembic output to export alembic files. So connect the merge node to it. First, you define where you want to save out the alembic file. Let's save it to our desktop and name it clones from Houdini.abc and click accept. If it is an animation, you can change the render current frame to render frame range and then click on this save to disk button. The non-commercial version of Houdini is not capable of exporting alembic, and you need to have at least the indie version of Houdini. I don't have that currently on this machine, so I'll need to use another one that has that export capability, but the process is the same. Just click on the save button, Now we'll be getting back to C4D and loading the ABC file there. Now back in Cinema 4D, let's hide and disable the cloner and import the alembic file. So from the file menu, choose merge. On my desktop, here is this clones from Houdini.abc file exported from Houdini. I'm just going to set the import scale to around 51 so it matches our cloner size in Cinema 4D. So here is our alembic file and it comes with 3 tags. The first one is a vertex color tag containing our color data from Houdini. In the basic tab of the tag, the name of the attribute is CD, like we had it in Houdini if you remember. The second is a vertex tag, is a vertex map containing our mask info from Houdini. And the third tag is another vertex map containing our random BW attribute. Now let's copy our material and assign it to the alembic file. Instead of the user data RGB node that we used, we can drag and drop the vertex color tag to the network and connect it to the color correction node instead of our user data RGB node. And now we have our color data from Houdini, which we can adjust it using the color correct node. And instead of our color jitter node, bring in the random BW vertex map and connect it to the range node instead of the color jitter node. Now, as we no longer using the color jitter, we can add a range after our random BW tag and set the output min to 0.5 and output max to 1.5. And there you have it. You can see we get a very similar result to what we had before. Now, if we want to generate our own colors from scratch using the mask attribute from Houdini, let's simply duplicate our material again and assign the new one to the alembic file and drag in the mask tag and use it as the beauty shader for now. I'm going to press Ctrl Tab and add a ramp RGB node. Use the mask map as the ramp input and connect the ramp to color correction input. Use the standard surface shader as the beauty shader and we can add any color we want here. Let's say a vibrant red as the first color, an orange as the second color in the middle, and a nice yellow as the last color. You can obviously change the colors, add more colors in between, but if you wanted the exact same colors from Houdini, you can use the vertex color tag, which was our previous material. Okay, and that's it. Let me know what you want to see next. Hopefully you learned something. Subscribe to MographPlus for more. Make sure to visit our website MographPlus.com or our Gumroad page at gumroad.com/MographPlus and check out our premium rendering and motion graphic courses for Cinema 4D, 3ds Max, Maya, Arnold, Corona, V-Ray, Maxwell, and so on. Please like, share, and subscribe for more videos from MographPlus. It was Kamel Khezri with you. See you next time, folks.